So let's get started with 3.3. The main theorem we're going to need for the first few problems is right here. So if some number c is a zero, then x minus c is a factor of the polynomial. So if c is a zero to a polynomial, x minus c is a factor. So for example, if these are both zeros, then they can be factors. So what they want us to do is create an h function, which is called h of x, I guess, and say, well, x minus each of these zeros is a factor. So that would simply become minus minus, so x plus 8, x plus 3. And you can see, right, if you plug in the negative 8, this zeroes everything out. If I plug in negative 3, zeroes this out. So minus 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 minus. So whenever you have a zero, then it is of a polynomial, then it is a factor written like this. So let's do another one. Number two. Okay, so number two, find a polynomial, we'll call it f of x, of degree 5. So it's got to be, all the factors need to add up to 5. And then you have a 0 at 6, 3, and negative 4, but negative 4 has multiplicity 2. And then one more 0, comma, negative 9. So we said we're going to call it f of x. So each 0, x minus each 1, will be your polynomial. But remember, this is multiplicity 2, so whatever the multiplicity is going to be 2. If they don't say the multiplicity, we're going to assume it's 1, so 1 on all of them, right? Now just deal with that sign and we're good. X plus 9. So whatever multiplicity they mentioned, just make sure you put that as your power. So given the zeros, you can find the function. Number 3, they just want us to divide. So most of these questions coming up will be about division in order to find your zeros or rewrite the question. But this is an easy one before it gets strange. Right, just divide each one by your divisor there. So you can separate the fraction like this and just divide them. And 18 divided by 2, that's going to be a 9. U6 divided by U3, remember that means you have to subtract them, right? 6 minus 3. 8 divided by 2 is 4. And then the powers are subtracted. 4 minus 3. So you get 9u cubed minus 4u. That's why we do some basic division. That's a u, not a 6. All right, let's go on to something harder. Okay, so now we got to do division, well, long division, which is kind of hard. Um, so if you've forgotten the algorithm or the pattern doing basic division, like let's make one up real quick. Example. Let's say you're doing 5 divided into 95, right? You say, okay, well, 5 goes into 9 one time. And then you do the pattern, 1 times 5, with the 5 underneath, and then you switch the sign, right? 9 minus 5 is 4. You're like, okay, now, is 5 going to go into 4? No, it doesn't. Bring the 5 down. 5 goes into that 9 times. 9 times 5. And your remainder is 0, right? Now, if there was a remainder, you would have a fraction. So, similarly, right, this is the pattern we're going to follow. So, if you remember the old school division, this is dividing into that one, so this goes inside the house. So this is where it's different. You do 6 into the first term instead of like just kind of like we did here, 5 into that first digit. Okay. So let me put that aside here. So the first step, 6x squared divided by x, right? Only use the first term the entire time. That goes in, right? This reduces into 6x, so that goes in 6x times. Then you do the pattern, right? 6x times x gets me this. 6x times a negative 5 gives me a negative 30. Then you switch all the signs. Okay, so this becomes a minus and that becomes a plus, right? So, and then you add them together. So minus, plus, let's just switch them. So we don't need that anymore. Because when you have a minus in front of parentheses, everything switches inside, right? There we go. So 6 minus 6 is 0. Negative 37 plus 30 is a negative, no, positive 3. Okay, so then we do, okay, well, does the x go into the 3x? Yeah, it does, right? So 3x divided by the x gives us a 3. So now we have plus 3. So 3 times that gives me 3x. 3 times negative 5 gives me negative 15. Bring down the 33. And then switch. So 3 minus that, right? It's going to become plus. This will become minus. To remove the one in front is distributed. I distributed the minus inside. This way I don't have to write so much. Right? You always subtract. So you're subtracting the entire thing. So swap both signs. Swap both sides here. So 3 minus 3, 33 plus 15. And that's it. But x is too big to go into 48 because it doesn't contain a factor like these. So the answer, right, the quotient is 6x plus 3. Oh, let me double check here. Oh, I think there is a small error. Here's my mistake. Negative 30 plus negative 37 plus 30 is negative 7. So that's my mistake right there. So you didn't make a sign error on these guys. Alrighty. So negative 37, be that. Okay, then what we should have had right here is x into negative 7. There we go. So then this would be negative 7. So let's start from the beginning. 6 into 6x squared gives me 6x. That goes on top. Then you do 6x times these two, gives me it gives me 6x squared minus 30, but then you swap the signs. So we did earlier. And then these cancel, 0. Negative 37 plus 30 is negative 7. Then you do x into negative 7, start the process over. That gives you negative 7, that goes up here. So now negative 7 times these two gives me these two here. So we'll start. So negative 7 times x, negative 7x, negative 7 times negative 5, positive 35, but that's going to change once I swap the signs here. That becomes plus, that becomes minus. So swap done. So negative 7 plus 7 is 0, which is what we need. 33 minus 35 is a negative 2. So remainder, negative 2. So quotient is 6x minus 7. Remainder is negative 2. So it's just this process over and over again. It's just that you have to have that little new rule and deal with the algebra. So let's do another one, or the next one. Okay. This is number 5 from the homework. Basically, we're going to go into this guy. Also, whenever you do this, you need to make sure you have every power. 3, 2, 1, 0. And if it's missing, you have to put a placeholder. Right now we have all of them, so we're good. Okay. The 3x goes into the first term, just like we did before. Right, so 9x cubed divided by 3x. 9 and 3 reduced into a 3. X cubed divided by x is x squared. So this is a 3x squared. And then we got to multiply this. So I'm going to do more of the uh, messy work over here. 3x squared times 3x is a 9x cubed. 3x squared times negative 3 is a 9x squared. And they all got to switch signs. So this becomes, remember, if you put a minus, just try a little more steps this time. Becomes positive, right? Negative 1 times that is negative 9. Negative 1 times negative 9 is positive 9. So that's why this becomes plus. And that's why this becomes minus. And then subtract. 9 minus 9. Negative 15 plus 9, that's a negative 6. Okay, so now back to the algorithm. 3x into this is not going to be. That's a negative 2x. So that's the next term. Now repeat the process. So the negative 2x times this stuff. So we're back here. Okay, so that's going to go under here. So these will switch signs, remember? If you have a minus like so, it becomes positive minus. This will become positive minus. And then go ahead and add them together. These are gone, which is the goal. 9 minus 6. There we go. All right. Looks like that would be a nice one. 3x goes directly into this one. So 3x divided into 3x is a 1. So cool. 1. 1 times all of this minus. Well, 1 times that is just itself, so we don't need to do that step. We gotta bring that 1 down though, and then do the minus part. So I'm gonna skip to this part here. Oops, sorry. Not on the screen there. Okay, plus 3. So this piece will become negative 3x plus 3. That's it, remainder 4. So quotient is the answer to your division. 3x squared minus 2x plus 1. Remainder is the 4. And that's it. So it can be very tedious and annoying, but it's just the same pattern over and over. You just be careful with the signs, distribute your negatives, reduce your powers, and redo the division, and we should be okay. It'll take some time to practice, but once you see it, it won't be too bad. Okay, let's do one more long division. So I've done 3 different types. This time, notice the one we're dividing into is out of order, and it's missing the quadratic term. So we got to rewrite it first. So this is still going on the outside. Well, we got to put the negative x cubed first, and then add a x squared term. So a 0x squared plus the linear term plus the constant term. So we got 3, 2, 1, 0. And they want it in this form. So the quotient, whatever we get on top, plus the remainder over the divisor. So we're actually rewriting this entire thing into this form. But the work is going to be the same. Okay, so 3x squared into that, just like before. That gives me a negative 2x. Now that goes up here. Then we multiply the negative 2x times the divisor. That gives you negative 6x cubed plus 10x, right? I'm running out of space there. Okay, so that'll be right here, negative x cubed plus 10x. Okay, so then we gotta do the subtraction, right? Don't forget. So that'll become plus minus. Distribute the negative. Once that's done, we don't need to write that anymore. Negative plus 6 is 0, which is supposed to happen. That first term should always cancel. If it doesn't, then you do not distribute the negative properly. And if you didn't put it on both, then this would be wrong. So 7 minus 10, no quadratic terms, we're good. There we go. Now we can't divide any further. X squared is too big to go in there. We can bring this down, but that's it. So, what does this mean? I'm gonna rewrite this pretty. So the original, rewritten, right? Well, that doesn't matter. This is how they wrote it. No, this can be rewritten as negative 2x plus negative 3x plus 4, the remainder over your divisor. So we rewrote the polynomial, this guy divided by that, this guy divided by this, into these two terms. That's what they want. They want the quotient plus your remainder over divisor. Kind of like how you did mixed numbers way back in the day. But anyway, I couldn't go any further, therefore remainder. Okay. So I'm sharing the example I'm doing right now because it's prettier and easier to understand on here. So basically, um, so this is a new technique. It's called synthetic division. Way easier than uh, long division that we just did. We did three of them. Now, it's easy to do synthetic when you're dividing by something like this. See how there's no number on the x, it's just a 1? So when you have that scenario, synthetic is best. Now, there's a little bit of trial and error involved, but you'll see how it's better. So first thing you do is set this up, right? So you have the negative 3, so all the coefficients, right? Negative 3, negative 13, 0x, constant 16. Okay. Now, once you have that, what you do is you say, okay, well, the 0 for this would be negative 4. So if it's plus 4, you put a minus 4 here. And then you start your process. So this is what you do. You bring down the negative 3. Then you do negative 4 times negative 3. This is positive 12. We put a 12 there. Then you add up negative 13 plus 12 is a minus 1. And then you do negative 4 times negative 1. That gives me a positive 4. 0 plus 4 is 4. Then again, negative 4 times 4. Negative 16. Add those up and you get a 0. So let me use their number. It's prettier. Right, there they are. So again, from the top, you bring down the negative 3. You multiply these two together to get this one. Okay, so negative 4 times negative 3 is 12. So this came about. Negative 13 plus 12 is a negative 1. So this came. And then again, negative 4 times negative 1 gives me this 4. 0 plus 4 is 4. You're adding these up. I added these up. Then negative 4 times 4 is negative 16. 16 minus 16 is 0. There you go. So this turns out to be a remainder. So whatever ends up here is the remainder. Since it's 0, we're good. So you're going to write the quotient. So this is actually the coefficients of your new quotient. It's kind of cool. So if you started with a cubic term, that's your highest power or your degree, then these will all be, since I did divided by a linear term, then I should reduce my new solution by 1 power. So negative 3, it's right here, is the new coefficient of the quadratic term. Negative 1, the new coefficient of the x. Constant 4. So I went from a cube divided by a 1, got a quadratic. So the result will always be 1 less. So this would be 2, power 2, power 1, constant. And if there was a remainder, you would add the remainder like this, but there isn't any, so it's just going to zero out. If I was dividing, if this was a fourth or a fifth power, then you'd have, this would be, let's say if this was a fifth, then this would be a fourth power, 3, 2, 1, whatever. If it's a third, then this one has to be 2, 1, constant. If it was a quadratic, then so forth, same thing, 1 less. So let me show you their work. So the -3, 13, and constant, remember, went right here. -3, 13, and the constant. We had to fill in the linear, so there's the 0. That goes there. The divisor, x minus r, remember, it's always the opposite when we have the zeros and factors. So they had divided by -4, or sorry, x plus 4, so therefore it has to be opposite. Your divisor will be -4, your r, they called it. Hence this guy. So once that's done, you can start the process. So first thing, bring the -3 down. So we said earlier. And then -3 times -4, right, gives me 12. So that's the next step. So they got the 12. Add them up, you get a 1 or a -1, right? Right here. Now start over, -4. Oops, sorry, lost my signal there. Okay, so -4 times -1 gives me the 4. 4 plus 0 gives me a 4. -4 times 4 gives me a -16. 16 plus 16 is 0. So now I have the coefficients for my new polynomial, the reduced one, which is here. And that's it. That's it. Okay. So same deal here. We need the -1 right there, -7. No linear term, and then 6. So 0 for the linear. So that's the setup, right? And then we start the actual pattern. We're dividing by x plus 7, so that means -7 will be out here. That's why they wrote it this way. So here we go. So we set it up, right? Set it up. Bring down the -1. -1 times -7 gives you a +7 right here on step 6. So -7 plus 7 is 0. So now -7 times 0 is 0, which is what they get here. Add those up, you get another 0. -7 times 0 again is 0. So the remainder is going to be 6. So we get remainder 6 this time. We start with a cube and then went to divided by a linear factor. So it should end up with a square. So this is the coefficient of a quadratic. And these are empty, so you just add the remainder here. 6 over the divisor. That's how you always write the remainder. Okay. But yeah, it's just a pattern. It's not too crazy. I kind of like that one better than the long division. Now, there's another idea that says, let me show you the theorem. If I plug in the number C, and I think when it's a divisor, that's the same thing as the output. So plugging in 3 is the same as dividing by 3 and getting the remainder. So let's say you did all the work, right? You plugged in these numbers here, right there. Then you use +3 instead of -3. That's the rule right there. Then once all that is done, you do your rules, right? Bring the 2 down. 3 times 2 is 6. -4 plus 6 is 2. 3 times 2 is 6. -1 plus 6 is 5. Then again, 3 times 5 is 15. 6 plus 15 is 21. So whatever comes up here is the same thing as saying P of 3, which is kind of cool. There's like another way to get your output. So instead of plugging in the 3 here, here, and here, you can just use this number. Same thing. So they're saying that the remainder, 21, is the same thing as plugging in 3. That's what they want you to see. They also ask for the quotient, but this theorem, remainder theorem, is pretty cool. There's just another way to get that number. Okay. I'll try to wrap this up because it's kind of long. Let's see here. Use a factor theorem to determine whether -3 is a factor. So remember we said that if it's a factor, then it is a 0. Then what you got to do, here's the theorem, right? The main one. I'll write this somewhere. If P has this factor, that is only true if P of C is equal to 0. And in the other direction, right, is if C is a 0, then you can write it as a factor. So it goes both directions. This is a if and only if statement, bidirectional. So both ways are true. So plug in 3, you get 0, therefore it is a 0. That's all you got to do is plug it in or do your long division. If you find out that it is a 0, then that means you can write it as a factor, x minus 3. If 3 is a 0, then you can write it as x minus 3. That's what they want you to do. Just verify. All right, that's pretty much it for 3.3.